In today's session, I am going to revising the class what I discussed in session 1 for first 5 to 10 minutes, and then we will see the new concept. So these are the things what I am going to covering under the subject data structures. So the first kind of the data structures, the basic data structures are arrays and linked list. These are the two basic data structures. So after this, what are the data structures we are going to learning, such as stacks, queues, dequeues, and trees, graphs. All these data structures we are going to implementing either through arrays or through linked list. Right, there are some set of drawbacks in arrays. Hence, all the kinds of the data structures are going to implementing through linked list. So anyway, both kinds of implementations we will see. Whereas in searching techniques and sorting techniques, mainly we are going to using a basic data structure array. Through arrays, all these searching and sorting techniques going to implementing. So first of all, these two basic data structures should be known, called arrays and linked list. And these are the some of the sorting techniques. I am going to discussing bubble sort, selection sort, insertion sort, quick sort, heap sort, and merge sort. And these are the various kinds of trees: binary trees, binary search trees, AVL trees, and B trees. Finally, graphs. So this is the content what I am going to covering under the subject data structures. Right, can you tell me what is the basic definition of a data structure? No universal definition. We can define a data structure in several number of ways. There is no standard fixed universal definition. So the simple definition is a data structure is a collection of large amounts of the data. Just a collection of large number of data values. That's the one simple definition. For example, an array is a collection of data elements of same kind of the data. Right? And another definition is a data structure is an arrangement of the data inside computer's memory. Of course, the data structure can be created inside the primary memory as well as secondary memory. So the arrangement of the data inside computer's memory is also called a data structure. So the stack arranges the data elements in one way based upon the principle last in first out. Queues is another data structure arranges the data elements based upon the principle first in first out. So another complex definition for a data structure is a data structure is a particular way of storing data and organization of the data inside the computer so that we can able to use it efficiently. So for efficient data processing, data accessing, the data structures are highly helpful inside the applications. Right? Suppose a program is said to be efficient when it is executes, it should execute within minimum time, and it should be execute by taking minimum memory space. Then only that program is said to be efficient. So what are the applications we are writing related to various kinds of the domains, such as networking applications or gaming applications or database applications related to any kind of the domain. The data structures are helpful in writing the efficient programs with respect to two parameters. One is time, another one is space. So if you want to write efficient programs, we should apply data structures inside the program. We should apply the data management concepts inside the program. Data management concepts means data structures. So a program is said to be efficient when we can say when it is executes in a minimum time and within minimum memory space. Right? So if you want to write like this kinds of efficient programs, we should use data management tools, data management concepts such as data structures. So there are so many areas where we are using data structures. In gaming applications, in database applications, in operating system applications, compiler related applications. All these are the areas where we are using data structures. And as I discussed in last class, there are two kinds of data structures: linear data structures and non-linear data structures. Linear data structures and second kind of the data structures are known as non-linear data structures. So what are the examples of linear data structures? Arrays, linked list, stacks, queues, all these are the examples of linear data structures. The linear data structures maintains a linear relationship between the data elements. That is, all the data elements are stored one after the other. Suppose whereas in linked list, the data elements are stored in contiguous memory locations. The data elements are stored in one after the other. That a linear relationship is maintained with the help of links. Of course, one element is stored in a memory location 1000, another element is stored in another memory location 2000. But all the elements are stored looks like storing in consecutive memory locations. With the help of links, the linear relationship can be maintained in the linked list. Already, as you know, in arrays, all the data elements are stored in contiguous memory locations in the format of a list. And these are the examples of non-linear data structures: trees and graphs. These non-linear data structures maintains hierarchical relationship between the data elements. Hierarchical relationship. Some sort of parent-child relationship or ancestor-descendant relationships are maintained between the elements with these data structures, trees and graphs. So anyway, about all these kinds of the data structures and their applications and algorithm techniques, various algorithm techniques, furtherly we are going to learning. This is somewhat the introduction about data structures. And another important point we should be known is, what are the various kinds of operations which we can perform onto the data structures. So very frequently performing operations onto the data structures are insertion. So another important operation very frequently we are performing on different data structures are deletion and display, or we can also call traversal. These are the various, and moreover another important operation is sorting. Another important operation is searching. These are the various operations we are going to performing on different kinds of the data structures. Right? So these are the some important points related to data structure. So what is a data structure? What is the importance of the data structures in various kinds of applications? What are the areas of applications of data structures? For what purpose we should use a data structure inside an application. So whenever you want to write efficient program which executes in minimum time and within minimum memory space, a data structure is required. And different kinds of the data structures, linear data structures and non-linear data structures. Depending upon the relationship maintained between the elements, the data structures are categorized into two types, and these are the frequently performing operations on various kinds of the data structures. Right. So copy these few points and then we'll see the next topic. Topic 1, Introduction to Data Structures. In continuation, of the last session, take down these points. A program is said to be efficient said to be efficient when it executes. A program is said to be efficient when it executes in minimum time and with minimum memory space. Next point. In order to write efficient programs, we need to apply certain data management concepts. Next point. Data structures are widely applied. In the following areas. 1. Number 1, compiler design. 2, operating systems. Number 3, graphics. Number 4, database applications, that is in DBMS. Next one, statistical analysis and package. So there are so many number of statistical analysis tools in computer science. In all those tools, data structures plays an important role, and in numerical analysis, artificial intelligence, finally simulation. Numerical analysis, simulation, artificial intelligence. Artificial intelligence. Next point. Side heading. Types of data structures. Types of data structures. Types of data structures. Types of data structures. Take the first point. Data structures are generally categorized into two classes. Data structures are generally categorized into two classes. Primitive and non-primitive data structures. Primitive and non-primitive data structures. Primitive and non-primitive data structures. Next point. Primitive data structures are the fundamental data types. Primitive data structures are the fundamental data types. Which are supported by a programming language. Which are supported by a programming language. Which are supported by a programming language. Some basic data types are char, which are supported by a programming language. Some basic data types are char, chr, int, float, double. Char, int, float and double. So almost all programming languages supports these basic data types, are also known as primitive data structures, right? So non-primitive, second kind of the data structures, non-primitive data structures. So what are the non-primitive? The data structures which are derived from primitive data structures, known as non-primitive. Next point, non-primitive data structures are those data structures. Non-primitive data structures are those data structures Non-primitive data structures are those data structures which are created using primitive data structures, which are created using primitive data structures. Examples includes linked list. Examples include linked list, stacks, trees and graphs. Examples include linked list, stacks, trees and graphs. Stacks, trees and graphs. Take down this flow chart. Copy the flow chart there. Data structures are of two types: primitive, non-primitive. Data structures are broadly classified into two categories. First category is primitive data structures, second category non-primitive data structures. These are the examples of primitive data structures: char, int, float, double. So we are not going to focusing on primitive. Again, non-primitive data structures are categorized into two types: linear data structures and non-linear data structures. Linear data structures and non-linear data structures: arrays, linked list, stacks, queues. One, trees. Number two, graphs. Non-linear data structures: number one, trees; number two, graphs. Number two, graphs.